Hi, everybody. I hope you're ready for the next session, and I hope that you all can hear me. If not, then give you a few seconds to complain in the chat or something like that before I move over to my presentation. Seems to be all right. All right. Then I move over to the presentation screen. Just as a little comment up front, I will not see your questions or comments in the chat until the end of the presentation because I'm on a different screen here and don't see that at the same time. Okay, but I will answer them all at the end of the presentation. What I want to talk about today is resilient software design and resilience as a whole in IT. So where we came from, where we are going to, what the challenges are, what we can do about them, a bit of a stock taking and a look ahead where most likely the journey is going. My name is Uwe Friedrichsen, and I work at a company that's called Codecentric. If you live in Germany, you may know it. If you don't live in Germany, most likely you do not know it. And in the internet, you find me with my handle ufried, usually at Twitter, also at Mastodon, if you prefer Mastodon meanwhile, and at Speaker Deck, and also my private homepage and my blog with ufried.com and some other places. So if you should figure out at the end of the talk that you don't have any question there, but maybe tonight a question comes along, so just ping me at Twitter or somewhere else. All right, let's jump in. Where do we come from? And if we talk about the past of resilient software design, we have first to look at resilience as the broader topic, the overarching topic. And if we look at resilience as the overarching topic, we have two perceptions from the past. The one is the perception that we see inside IT and still often see at the moment, and the perception that we see outside of IT. Let's start with the perception of resilience inside of IT. And inside of IT, most of the time, resilience is a synonym for fault tolerance or robustness of systems. So if people talk about resilience or resilient software design, most of the time they talk about fault tolerance. Fault tolerance isn't quite old topic, actually. It started about 70 years ago. So the oldest reference that I found was to the SAPO computer, which was built in 1951, which had some kind of memory redundancy built in, so some kind of fault tolerance there, or the NASA computers for the long life, no maintenance computing, which they used in Apollo or the Voyagers. Later on in the 60s, so in military airplanes, also in telecommunication switches, the tandem computers. So tandem was quite famous for their NSK, for their non-stoppable kernel operating systems, and all these things that emerged back then about half a century ago and longer. And what was common back then is that fault tolerance usually was solved at the hardware or the operating system level. And software developers basically didn't care too much about that. They just said, okay, there's something, maybe some constraints. So not everything's allowed to do in software development. Just basically was it. And it remained that way, basically, that it was handled at the hardware, the operating system, or the infrastructure level until maybe so the early 2010s. So when cloud and microservices became popular, and then we saw these things like the Netflix OS, which they did a lot of talks about, and especially the Hystrix library for fault-tolerant handling of communication. And so suddenly the software development people became, so the software development department became interested. Wow, that's interesting. That's interesting stuff. And it was also around the time when fault tolerance started to be called resilience. Still, it had a focus on fault tolerance. And meanwhile, if we move more towards 2022, we have a lot more support of all these things like timeout management, retries, circuit breakers, and rate limiting and scaling up and down and failovers and so in the infrastructure level again. So we have the service meshes, API gateways, the cloud infrastructure, and all these things. But still, we At the moment, we don't see a lot of attention in the software development community. Most of the time, also in the past, in the 2010s, then we had this situation that, yeah, let's do something about fault tolerance, about resilience. And no, we don't have the time for that. And we need all these features. These business features are much more important, and we only have the budget for those ones. All right. So that's more or less the perception that we had in the past about resilience in IT. So if we look outside of IT, we get a quite different perception, because outside of IT, resilience is not the same thing as fault tolerance. So it's something very different. There are a lot of domains which deal with resilience outside of IT. So like psychology, organizational theory, or supply chain management, and all these other domains that are listed here. And it's not a single origin that we can figure out. So all these, everywhere somehow emerged these concepts of resilience, and that is important. And so it evolved then one by one. And they had different definitions, but quite often we see there that they have a different focus, that they say, well, fault tolerance and robustness, that's about handling known failure modes. That's fine. But resilience is something different. Resilience is adapting to unknown failure modes, to the surprises that we cannot anticipate. So, but still, it's not a generally accepted definition. We see some people who insist that there's this distinction. Others say, no, no, robustness is part of resilience, but it's not all of it. And sometimes we see other definitions. And so it goes a little bit forth and back. And the common ground basically is then that resilience is more than just robustness and fault tolerance. So if we talk about resilience as a whole, it's more than just adding a circuit breaker to our code. Okay, so that's what we learned from outside of IT. So bottom line of the past is it's a broad field, no single origin, no generally accepted definition. So there's still a little bit of struggle depending on who you're asking. Inside of IT, still most often used as a synonym for fault tolerance, and yeah, still quite often people expect it to be handled at the infrastructure or operating system level. So as I say, well, it's on software development, yeah, don't know. Let's handle the service mesh because there's a circuit breaker. Why should we do anything about that? And the product managers and product owners who come along and say, no, we don't have any time for anything like that. We need to implement features right now. Okay, so much about the past. Where are we now? Well, mixed feelings, mixed emotions, I would say. It became a little bit quiet about resilient software design, resilience in IT, I think. So there was this hype about 8 or 10 years ago, and people said, oh, wow, that's cool. That's something. We want to do that. We want to do that. And wow, that's not that easy. Wow. And our product manager always say we don't have time for that. And can't we buy a tool for that? And oh, here's a service mesh. Let's use the service mesh. We can do it using the service mesh. And so it's more or less the usual story. The surprise, this would be, it's not good, but it wouldn't be that surprising. If not, at the other hand, microservice became so popular so that everybody wants to do microservice. I mean the forerunners, meanwhile, say, well, maybe don't do microservices all the time, but still, I can go to mostly any project in any bigger enterprise and say, how are you doing the implementation? Oh, we use microservices. And with microservices, which means that you create a distributed application, you would expect resilient software design being much more important topic. But actually, quite often, I don't see that. So I see the architects mostly ignoring the effects of distribution, so doing the design as they always did, not caring about all these imponderabilities of remote communication when doing their designs, and also the developers not doing anything about that. Of course, everybody else who's not in the development department expects everything to become faster and cheaper because that was the usual sales story that was repeated over again. Oh, we have to pick up this new paradigm. This time it's called microservice. Before it was SOA or SOA, or it was something like CORBA before, or EJB in between, or DCOM, or you name it. And the story is always the same. We have these new things much easier for us, and it's so much simpler, and we can have all this reusability, and we get so much more flexibility, and it will pay for itself. And well, it never did. It also doesn't pay for itself here, but well, that's everybody else says, well, you're doing microservices, so it must be faster and cheaper now. Or why isn't it? And so more pressure. And the development teams still expect infrastructure to handle all the fault tolerance and availability issues. So, well, we design as we always did, and operations folks mostly curses a little bit and is stressed out because they have then to handle all the problems that they inherited from microservices. So it feels a little bit like you build it, you run it from the early DevOps days, turns into something, you build it, you ignore it. So build things like as you like and neglect the consequences of your acting. I know it's a little bit exaggerated, but it's a bit like it feels a bit like that for me. You may ask yourself, why is it such a big problem that if we neglect fault tolerance and resilient software design when we do microservices? So let's look at that question. And for doing that, we have to briefly look at distributed systems. And we could talk about distributed systems for the rest of the day or the rest of the week or the rest of the month, and we still wouldn't cover everything of that. So I give you here the shortest accurate definition I've ever seen about distributed systems, which is from Werner Vogels, CTO of Amazon. And what he says is, everything fails all the time. And it's not because some people at Amazon are dumb. They have very good engineers over there. The problem is that distributed systems, they rely on remote communication. And remote communication gives you some kind of non-deterministic behavior. So they have some failure modes in remote communication, so that other systems do not reply at all, or only sometimes reply, that they create latency in the replies, that the state of the other system doesn't fit your state, and therefore you get replies that you can't process in a sensible way. Or all these things can happen. And this gives you this non-deterministic behavior when accessing other processes. So in terms of if a task completes at all, or about message ordering, which also gives you effect of out of order messages, or if about this different perception of the global state in the different nodes, which gives you new kinds of problems, and communication, timing, so latency, and all these things that are going to hit you then. And infrastructure cannot completely hide that from you. So it will hit you at the application level. And now you could come along and say, well, why can't it hide everything? I mean, there's a lot of things that infrastructure is doing for us. For instance, there's timeout management in there. So they figure out timeouts for us. They do retries, automatic retries. And if some service is down, they do the failover for us. And they fire up new instances down, and they do the auto scaling for us. And also they do the rate limiting for us and escalation strategies. So notify the administrators everything goes wrong. And they also have something like smart update strategies that avoid our downtimes, like rolling updates or canary releases and all these things. So can't we leave it to the infrastructure? And the point is, yeah, it's quite a bit. That's good that we have all this. And there's a lot more than we had 10 or 15 years ago when I started with microservices, for instance. We had to build all these things inside our processes and either using libraries or building the libraries. But infrastructure still can't handle everything. For instance, not all failure modes are supported. So infrastructure cannot figure out if the answer that a different server gives you makes sense for you. So if your states are in sync, or your expectation about the global state are in sync. So if the both nodes are out of sync, infrastructure can't figure out that. or it also doesn't support all patterns. For instance, idempotency. Idempotency is a design issue. So how you design an endpoint. So if it's idempotent or not idempotent, and if your infrastructure fires automatic retries at non-idempotent endpoints, well, good luck with that. Or fallbacks. So your infrastructure comes back with you to you and says, well, I had a timeout and I retried and I still have a timeout. So here, now it's up to you. And you don't have a backup plan for that. What are you going to do? Well, just log it and continue. Probably not a good idea. So you have to handle that. Also, not all features are always everywhere available. So on-premise auto-scaling on premises systems, well, often you don't have that, even if you would use that. You might need to augment the stuff. And finally, so you also get just some undifferentiated coarse-grained actions usually at the infrastructure level. So assume a service A, which tries to reach out to a service B, and so sends a request to service B, and this service B has, say, 5 methods in its endpoint, and 2 of those methods you need very fast answers due to your business case. So to your use case, you need very fast answers, and you can only do 1 retry. And for the other 3 ones, it's okay if the answers take longer, and you can do multiple retries with exponential backup, but you only have 1 retry logic and 1 timer that you can configure at the infrastructure level. And so with all these things, in the end, the effects of distributed system of distribution will hit you at the application level. And it will hit you if you build microservice systems or any kind of distributed systems. And all our system landscapes these days are distributed in some way. And so I would have expected more resilient software design, but most of the time I don't see it. I still see the development teams developing their software as if, well, good old times would still be rolling and infrastructure could handle everything. But it's not true anymore with these distributed system landscapes. And we have one more effect that's at a different level that I would like to mention here. That is that our IT landscape complexity grows and grows and grows and grows. So that makes things even more complicated. And there are a lot of effects why this complexity explodes more and more. And one of these, I listed here a few of them that at least we may be able to influence in some way. So the one thing is that we still handle everything as projects in most companies. So most IT developments are projects, and projects, they say, okay, here's my project scope, here's my local scope. I try to optimize within my local scope, and everything else I do not care about. And so they do their local optimization, their local way of doing things, and just everything else just good enough, all this integration with other systems and so on. And so basically the complexity of the rest of the system landscape is ignored, and you do not add complexity, you multiply complexity by doing all these local optimizations. Also, we are so fashion driven. I mean, we are more fashion driven than clothing, basically, in IT. So, oh, there's a new thing, yeah, we have to use it. Oh, there's another new thing, yeah, we have to use it. Oh, there's another new paradigm, yeah, we have to use it. And and it's great, it's great, it's great. Are there any trade-offs? Oh, no, I don't care about trade-offs. It's great, we have to use it. And so then we try to add that to here. We add a new technology here, new paradigm there, new tool here, and a new technology there, new paradigm, and a new tool, and so in the end, complexity, well, of the overall system landscape multiplies. And I think that eventually all the system landscape that we are highly dependent on will eventually collapse beyond repair. At the moment, some stressed out operations guy do some magic to keep it up and running, and nobody really understands what's going on. And so hope is our best friend, but eventually I don't think that it will persist in the long run. To fix, we need to address this issue in the next years, because digital transformation means that we become more and more dependent on the run, on the uptime, on the robustness, on the reliability of these system landscapes in our business and our private lives. We cannot switch those systems off anymore. And any kind of downtime is a problem. So it's almost like electric, like power supply or anything like that, like electricity, meanwhile. And to fix that, we would need something like resilience thinking beyond plain application robustness. So we really have to, how can we handle surprises? And IT systems can't handle surprises. But that's, as I said, there's a lot more than just resilient software design. So focusing on the application robustness, but we also need the application robustness. So we have these complex system landscapes. We need robustness in them. So we need to be able to handle if some other system is down. We must not design our systems in a way that we expect everything around us to be up and running 100% of the time. And this is the predominant paradigm I see in development projects still, this 100% availability trap, which is still there. We must get rid of that. And we have to get, and then on the other level, we have to think about, okay, how can we handle surprises, which is another topic. But both things are needed. I mentioned this here because if we look into the future, I will come back to that. For finishing up this part, so current times is that companies slowly start to realize there might be a problem. But actually, they don't realize that there might be a problem in the IT system. They realize that they have a problem at the business level because there are so many unexpected adverse events. So we have crisis, we have the COVID, we have the war in Ukraine, we have the gas crisis, we have the supply chain problems, and so unexpected adverse events become the norm, and they don't know how to handle these properly. And also the markets, the customers do not respond anymore how they were expected. So it's not predictable. Success is not predictable anymore, and all these things. And so we start to hear the term resilience more often in business speak. We still don't hear it that often in IT speak. So, but if you think about digital transformation, and some people realize that, is that digital transformation in the end means that business and IT have become inseparable. It's the same thing. It's the same side of the same coin. And on the other side, there's the market and your customers. And so business is IT is business. So whatever you do to your IT, you also do to your business, which means if you run your IT as a cost center, and this means that you also run your business as a cost center in some way. If you only try to maximize efficiency in IT and do not care about resilience, yeah, you also maximize efficiency in some way in your business, and you do not care about resilience. But we need resilience there. But still, well, it's a big change, and old habits are strong and old practices, and nobody gets fired or making the numbers on the balance sheet a little bit better at the end of the year. So, well, maybe let's neglect resilience a little bit more for the short-term gains. So urgency always trumps importance. Bottom line of current day is, so there's a growing understanding, a slowly growing understanding that resilience is needed. Still, it's not really there. So, and people do not really know what to do. And also in IT systems, we have growing problems, especially due to the exploding complexity of our system landscapes, and still investments are still scarce. With all that, where it's going, what will be the future? My personal expectation is that resilience will become the most important topic of the 21st century for companies, alongside with sustainability. And if I talk about resilience, I talk about all types of resilience. So at the organization level, process level, product level, also IT level, human level, and all these. And if I talk about sustainability, I also talk about all types of sustainability: ecological sustainability, economic sustainability, social and human sustainability, and technical sustainability. So it's a broad topic. And I don't think that these topics will become very important in the next years because people have an epiphany, but just because they don't have any other choice. I mean, if unexpected events become the norm, just trying to optimize your production processes for more cost efficiency really doesn't help you. I mean, you have to be flexible to respond to surprises and unexpected events. You must be fast, not cost efficient. I mean, cost efficiency is okay, but what does cost efficiency help you if you're on the completely wrong track and you simply do not survive the next adverse situation? And that's this realization slowly but surely sinks in. But before we get there, I think we have some challenges that we need to solve first. So some homework that we need to do to get there. And the first one, it is maybe addressed towards the resilience engineering or resilience domain itself. So we still have a lot of strange fights about what is resilience, what's not. Oh, no, it's not resilience what you're talking about. What I'm talking about is resilience. No, that's not. It's what I'm talking about is resilience, not what you're talking about. And forth and back and so these struggles. No, robustness does not belong to it. Yes, robustness does belong to it. No, it's only about anti-fragility. And yeah, but what would you do if you say, oh, maybe resilience is an important thing, and I look over to the experts and see them fighting all the time, who's right and who's wrong? I mean, I would just turn away and do whatever I did before, maybe optimizing for more cost efficiency or something like that, instead of listening to them, let them finish their fights first. So we have to settle these fights. And here's my little suggestion how we could define things. Resilience as a whole, I would define the ability to successfully cope with adverse events and situations, including all three types of what people are fighting about. Handling expected adverse events and situations, which is robustness and includes fault tolerance and IT systems. Handling the unexpected adverse events and situations, which is handling surprise. And improving due to adverse events and situation, which is the idea of anti-fragility. So something bad happens to you, and after you handle that, you're stronger than you were before, which is the best part of it. And resilient software design is about designing and building software-based systems in a way that it improves their dependability, and by doing that, it supports resilience according to this other definition I just have on the top of this slide. So, I mean, that's quite inclusive definition. I think that's good enough. Still, you can say, well, I focus on handling surprises, the unexpected stuff. I focus on handling the expected stuff and making your system landscape more robust or your organization more robust. Or I focus on improving anti-fragility. But we need all of that in the end. The next one that's probably the hardest one. Breaking these traditional company habits. So most companies focus on maximizing efficiency. Well, that's a problem with that. It cripples resilience. I mean, maximizing efficiency. If you're in a predictable market, everything's predictable, success is predictable, then that's a good idea. So whole industrial production started with the implicit assumption, or in the beginning it was even the explicit fact, that demand is a lot higher than supply. And in such a setting, there's predictability regarding success and regarding what you need to do to be successful. And when you have this kind of predictability or certainty, what you need to do then to be highly successful is you try to optimize your production processes in a way that you can produce your goods that you can produce more of your goods in a more cost-efficient way. So the less it costs to produce things, the more you can produce, the more you can sell, the higher your margin is, the bigger your profits are. Straightforward. But if there's uncertainty, if you have no idea if what you're doing will create any kind of success, that's a bad idea. Then in those situations, you need something else. So you will always hit the situation that something comes back to you and says, well, that's not how you expected it. And especially then if unexpected events, surprises come, you have a big problem. Because if you maximize efficiency, you reduce variance. I mean, you can only maximize a little bit of efficiency or improve a little bit of efficiency without reducing variance. So, and after this little bit, you have to say, okay, the allowed, so what's possible, what we can accept, the acceptable conditions for our production become smaller and smaller and smaller. And by making these acceptable and expected conditions smaller and smaller and tighter and tighter and tighter, you can optimize your production processes more and more and more, because there's not these unexpected things that you need to handle. The whole quality management systems like Six Sigma and so on, they're also always about reducing variance. Again, in industrial market, it makes sense under certainty, but under uncertainty, doesn't make any sense, because all these things outside of your expected conditions, this is what's the new normal. And so you will be very vulnerable to all these things. And also you try to utilize everything by 100%, which means you do not have any wiggle room more to handle surprises and all these things. So only thinking about efficiency is a big problem. You have to give up a little bit of efficiency to be able to become resilient. Also, the short-term thinking gives us a problem then, because now we only say, yeah, right now for the next 3 months, but surprises may happen in 5 months or 9 months. So you neglect resilience again. And also this minimizing of costs that also says, no, we don't have any time for making any building any robustness in our applications or caring about resilience and all these things. Well, I said that will be probably the biggest change. Maybe we cannot force these changes, but maybe we can influence this kind of change. So doing our part to make it happen. Then if we go back down one more level, understanding resilience in IT, we have to understand that this is more than just building in a circuit breaker or doing something for IT systems. So to really become resilient, we must also be able to handle some kind of surprises, unexpected events, really unexpected events. And that needs humans. And even if the circuit breaker says, oh, well, the service goes down, it goes down, it goes down, it goes down, quite often there's a bug in there, or we did something wrong and we have to fix it. And we need humans to fix it. We have to build an update and do that. And we have to detect it and observe. So observability and all these things play together, but it's a socio-technical topic. Resilience in IT. It's not a technical topic alone. And especially, it's not a tool, technology, or product topic. So whoever vendor will come to you in the next 5 years, no, it's not about their tools or products. Technology can support, but that's it. And if we go down one more level, we are back to resilient software design. And here you have to realize it's nothing which is completely solved at the infrastructure level. Infrastructure can support us, but we have to take care about that at the application implementation level. And additionally, we need very tight ops dev feedback loops to be effective, because what we do in development becomes effective in production, or it does not become effective. And we have to learn about that. It is a continuous improvement loop, basically, what we need to set up. And finally, it's a lot about proper functional design. If we set up our service design in a way, say, okay, service A needs service B to satisfy, to fulfill the request it got from the outside, and service B is down, then you can have a dozen circuit breakers in between. They simply tell service A, by the way, you're dead. So you created a cascading failure. Service B goes down, which also tears service A down. And what does this mean? Cascading failure. See, you violated the basic idea of isolation, the basic idea of fault tolerance, making sure that your system does not go down as a whole. You just implemented a cascading failure due to a bad design. So you have to take care about functional design. That's quite some homework we need to do, don't we? And now you may be paralyzed, you may resist, or you may say, well, I think it's worth going down that road. We need to do something about resilience and resilient software design. But where can I start? Here are a few recommendations, not complete, but a few one that might help you. Let's start at the lowest level now. Resilient software design, I said, we have to start at the functional design. We have to strive for functional independence of our runtime units, of our services, or whatever you're using. So that you don't have that situation that service A calls service B, and if service B is down, service A can't do its job. So you don't want to implement fallbacks everywhere. So look at the behavior of your system. Look at the use cases, look at the user interactions and try to group them together in some way, and do not try to distribute them along multiple services. This makes you brittle. Putting them together. And by the way, do not start with a data model. Data model gives you these highly coupled brittle system landscapes. So, and if you got this one right, then go for resilience patterns and your circuit breakers, your bulkheads, your throttling, and all these things come along. They support you with that. And the last comment over here is then domain-driven design, especially the strategic design, can support you with figuring out this right functional design. But it's not a panacea. I also have seen a lot of domain-driven designs, so DDD designs, which were not really domain-driven, but something else. So people used names of the patterns and applied them to what they always did before. We still see that. So it's not a panacea. Moving one level up, regarding the whole system landscape, so this exploding complexity, we have to find that complexity. We have to simplify our landscapes, our overall system landscapes in some way, because more complex become, the more brittle they usually become, the more error prone they become. Nobody really understands what's going on. So we do not only get expected problems, but also unexpected problems. So you have some emergent behavior in there and all these things that we don't want to have. But that's nothing which goes simply by adding some more resilient software design. That's more really about resilience thinking and its coordinated efforts of infrastructure, applications, and organization level, and all these things coming together. Maybe enterprise architects can help, but not by dictating upfront what to do, but by grooming after the fact and saying, "No, we see here something going wrong. You already have pain. We have a solution for that." And they also have some budget to fix things and improve things and so on. That could be helping. So making them part of a continuous improvement process. If we go one level more up to the IT organization as a whole and the processes there, we need feedback loops, lots of feedback loops from where here's an idea for a business feature until it's down in production and the customer can use it. So, and feedback loops all along the way, because we try to make this way through the IT value chain as short, as fast as possible, because the faster we can respond, the faster we are able to detect if something goes wrong, and the faster we can also respond to unexpected events and to surprises and all these things. So it makes us more resilient. Speed makes us more resilient. But if things go wrong along the IT value chain, it makes us slow. And so if an error happens downstream, often it happens because somebody did something upstream. And so we need the feedback loop and say, well, what you did up there, it has had the following effect over here. That's not good. Oh, wow. Let's figure out together how we can fix that and how can we ensure that it doesn't happen. So we need all these feedback loops. And this is all continuous improvement process in the end, because we won't get it right with a single initiative or big plan or anything like that. It's ongoing. It never ends. So reserve some capacity for that. And of course, include chaos engineering to figure out if your measures worked for resilience and resilient software design, and also for detecting not yet known failure modes. Then second last is the product, the business product level. So what products or service you offer at the business level. And here my recommendation is make them simple. At least try to influence your product manager, product owners to simplify those things. These feature monsters are hard to become robust. They are always in some way hard to run, to manage, to change, bugs that crawl in, and if you then turn them into microservices, it makes things even worse. So try to make sure that features that are rarely or not used or regularly removed, that they don't grow and grow and grow and grow, but that it also shrink. I mean, it doesn't help if we try to make things great at the IT level, if at the product level it's all messed up. So it needs to work together. And we have to provide the business metrics for the product managers, the product owners to learn how well their features are accepted at the market, if they are successful or not. So if they want to continue the development of these features or if they want to remove them. As Antoine de Saint-Exupéry tended to say, perfection is achieved not when there's nothing more to add, but when there's nothing more left to take away. You should remember the sentence once in a while. And finally, regarding humans, it's all about humans in the end. That's a big lie in IT. That's about computer systems. In the end, IT is about humans. These humans are stressed out a lot with handling all these unexpected failures, the expected failures, and all these other things. So, and to make their lives a little bit easier, at least we should try to provide them with great user experience wherever we can influence that. So for good APIs that they can use, good user guides, and make the system simple to use, and all the things that we can influence, a bit of the documentation and training for the people to make the unexpected boring in some way. So if something bad happens, well, we know how to handle that. We had a lot of training for that. So maybe we can influence that too. Okay, was a lot of stuff. Let's come to an end and sum that a little bit up. I talked about resilience software in the past, and we figured out that in IT it was quite often used as a synonym for fault tolerance, but in the broader field it's much more than just fault tolerance. It's more about also being able to handle surprise, robustness, handling surprises, even up to anti-fragility. In IT we had a little hype, but which wore off after a while. These days, we don't see too much investments into resilience at the moment, at least in IT, but it becomes more and more relevant, or it will become more and more relevant in the next years because these unexpected adverse events have become more and more the norm. So that anything, that predictability basically has faded away, and that uncertainty is the new normal. And uncertainty, you have to prepare yourself how to handling the unexpected. And that's what resilience is about. And it needs to be augmented by robustness in the IT systems, of course. The awareness increases, but still too little is done. Which means we have still a lot of homework to do. You might say now, wow, that's a grim prediction, and where's the image of the abyss that we all fall into? I don't think we fall into an abyss. I think at the end, it's a great opportunity to make things better, to improve the situation, also to improve the situation of all the people who are affected by that. And I love such a situation. We can make things so much better by doing our work, by focusing on making systems more robust, by helping to introduce resilience into our organizations and all these things. And I think it's really worth it. So that's what I had as a little bit of stock taking and look ahead. And hopefully it gave you some ideas to ponder, and maybe you have some questions now. And if not, if the question comes up later to you, then reach out to me at Twitter or wherever else you like to reach out to me. Okay, that's what I had for you.
Thank you, Uwe, for this excellent and very interesting talk. We have some questions from the audience. So let's start with the first one. Uwe, would you recommend any books on the topic of resilient or fail-safe development?
Oh, that's a hard one, actually. I mean, the book that I always recommend is Release It from Michael Nygaard. And Michael doesn't pay me anything for that, but it's an excellent book about writing production-ready software. It also handles a lot about fault tolerance. it also handles more aspects which are important to create really production ready and good systems for production. But that's an excellent start, I think.
Okay, great. The second question, do you think we learn something about building resilient software by looking at resilient systems in other disciplines? For example, biological systems are extremely complex, yet remarkably resilient.
Well, the very short answer is yes. There are two topics. If we go into, there are two ways how we can look into that, I think. The one is we can look into the domain of resilience engineering, so safety critical systems. People who build safety critical systems, they did they build robustness into their systems for many years, and they have good ideas how to do things and how to make systems reliable and dependable, and also how to organize their process and organizations in a resilient way that they also can handle surprises. And if we look into biological systems, for instance, what I just started to look into is organic computing. That's a science discipline basically at the moment. They exactly look into biological system and say, well, this swarm behavior and all the other things, they create kind of resilience or emergent resilient behavior inside the system itself. And they try to apply that to IT systems, but it's a research domain. So it's not yet ready for production. And it has some caveats in the way that especially these are self-organized and people always get afraid if they hear about that they lose control. So you have to give up a little bit of control over the system, and this will exhibit emergent behavior, and you have to get used to that. But most definitely, yeah, it makes sense.
Okay, thank you very much, Uwe. It seems we don't have any questions left. I'm pretty sure everyone enjoyed your talk, so please make sure to give Uwe your feedback in Hoppen. Yeah, and thank you very much, Uwe, for being with us and sharing your experience and your thoughts. And yeah, enjoy the rest of the SAQB.
All right. Thanks a lot.
Take
Great to be
care.
here.
Bye.
Bye.